When we think about the brain, our minds usually jump to the cerebral cortex, that big, wrinkly outer layer that does all our complex thinking. But deep inside, there's this powerful middle management, a whole set of structures that are running our inner world with just incredible precision. So today, we're going to pull back the curtain and meet the brain's deep bosses. Which really makes you wonder, right? Beyond your conscious thoughts, who is actually running the show in there? We're about to meet these hidden structures that are sorting every sensation you feel, smoothing out every move you make, and basically shaping your feelings and your memories. Okay, you ready? Let's dive in.
All right, first up on our tour is the thalamus. The best way to think about this structure? Imagine it's the incredibly busy and unbelievably important central mailroom for your entire brain. It is the one and only gateway for almost everything you experience from the world around you.
Now, the key thing to get here is that the thalamus isn't just passively passing along messages. Oh no, it is a highly active, super smart sorting station. Every single sight, every sound, every touch, it all has to pass through the thalamus first. And the thalamus decides what's important enough to get sent upstairs to the cerebral cortex for you to actually become aware of. It's literally the gatekeeper of your perception. So when it's working like it's supposed to, you don't even know it's there, right? Sensation just feels seamless. But what happens when this central relay station gets damaged? Well, the result can be absolutely catastrophic. We see this in something called thalamic pain syndrome. A lesion here can make a light touch, even just a gentle breeze on the skin, feel like excruciating, burning pain. And this just perfectly illustrates one of the core principles of neurology. Where the problem is located determines the kind of deficit you see.
Okay, so let's move on to our next manager, the basal ganglia. Now, if the thalamus is handling all the incoming information, the basal ganglia are like the quality control experts for all your outgoing actions. They don't actually start a movement, but they refine it. They make sure it's smooth, purposeful, and, appropriate for the situation.
The way they do this is it's just a constant, delicate balancing act. See, the basal ganglia operate on two main pathways. You've got a go pathway that basically gives the green light to the movements you want to make, and then you have a stop pathway that slams the brakes on all the unwanted extra movements you don't want to make. When that balance is perfect, you get fluid, graceful action.
But what happens when that balance is thrown off? The consequences are profound. This is exactly what's going on in Parkinson's disease. A little area that produces dopamine, called the substantia nigra, starts to break down. And without enough of that dopamine, the go signal gets a lot weaker and the stop signal gets way, way stronger. And the result? You guessed it, the classic motor symptoms of Parkinson's: rigidity, where the muscles are stiff, and bradykinesia, which is just a slowness of movement.
And you can see why this is so critical for doctors. By just carefully observing a patient's muscle tone, a neurologist can start to figure out exactly where the problem is. If they try to move a patient's arm and it resists with this constant lead pipe-like stiffness, that points straight to a problem in the basal ganglia. But if the resistance sort of catches and then gives way, or it gets worse the faster you move it, well, that's called spasticity, and it tells the doctor the problem is in a completely different part of the nervous system. It's like neurological detective work at its absolute finest.
And finally, let's meet the managers of our inner emotional world and our memory, the limbic system. Now, this isn't just one single structure, but a whole collection of them, all working together to create that rich tapestry of our feelings, our motivations, and our own personal history.
Let's zoom in on a real star player in this system, the hippocampus. And calling it the architect of new memories, that is the perfect way to describe it. It takes the raw materials of your everyday life, your short-term memories, and it carefully builds them into stable, lasting memories that you can go back and retrieve later. Without this architect, you literally could not build a personal history.
The clinical reality of what happens when the hippocampus is damaged, it's one of the most devastating conditions in all of neurology. A bilateral lesion, and that just means damage to the hippocampus on both sides of the brain, it results in something called profound anterograde amnesia. This person can remember their past, everything up until the injury, perfectly, but they are completely, 100% unable to form any new memories. They are, in a very real sense, permanently stuck in the moment the damage occurred.
But the limbic system isn't just about memory. It's also the wellspring of our raw emotions and our deepest drives. And that's exactly why it's so tightly connected with the prefrontal cortex, the part of our brain that handles judgment and decision-making. The prefrontal cortex acts like a crucial brake, giving us control over those powerful limbic impulses. But if that connection is damaged, a person's entire personality can change, leading to disinhibition, where they might say or do things that are completely out of character.
So as we've seen, whether we're talking about something as simple as making a smooth movement, or perceiving a gentle touch, or something as profound as the very foundation of our memory and who we are, these deep structures are absolutely critical. They work silently, behind the scenes, but their function is essential to everything we do.
And this brings us to what is, without a doubt, the single most important principle in all of clinical neurology. The big takeaway from all of this. And that is, location is everything. A tiny bit of damage can have dramatically different effects depending on whether it hits the thalamus, the basal ganglia, or the hippocampus. Understanding where the problem is, that is the first, most vital step to understanding what the problem is.
So I'll leave you with this to chew on. If our sensations, our movements, our memories, and even our personalities are so profoundly shaped by these deep automatic managers that we're not even aware of, what does that really say about who we are, about the nature of the self? Where does the brain end, and where does the person truly begin? It's a pretty fascinating question.